we are continuing with internal, epicyclic and other special gearing. And today's lecture is on a really special gearing which is called reverted gearing, and also I shall discuss about the conventional differential gearing, and later I will show how reverted gearing also can be used as differential gearing. In this lecture, I shall cover first I shall discuss about reverted gearing, then possible input output in reverted gearing, then transmission ratio, next an workout example to estimate the transmission ratio of reverted gearing, and as well as the possible direction of rotation. Differential gearing with reverted gearing, that I will also discuss. Next, I will come to conventional differential gearing which is used in automobiles, comparison of reverted gearing and differential gearing. Now, what is reverted gearing? If we look into this figure, then in this figure, first of all, this we looks something like a drum for belt drive. This is a not flat belt, but the other belt drive with a groove is there. Now, inside there is a gearing arrangement. What we look? First of all, this is gear 1. This gear 1 connected to a shaft. This is gear 1, and it is connected to a shaft, and it is mounted from one side, and then it is meshing with a planetary gear of teeth number Z2, and with Z2 integral is Z3 which is having higher teeth number. Then finally, Z3 is connected to Z4, this is 3, this is 2 and this is 4. And as you see that this shaft is mounted with bearings inside the gearing, but however, the bearing arrangement may be different. We can say that this is on a fixed frame, this bearing arrangement with fixed frame and maybe with the rotating drum also as shown here. This means that this gear can be rotated from this side, this gear can be rotated from this side separately, independently, and these two will be output. I will come to that, and in this case input is this drum. Now, it is an epicyclic or planetary gear drive with external toothed gears. And in general, the planet carrier is input, and there may be 3 possible outputs. First one is gear 1, that means this I have already shown which is gear 1, it is marked by Z1 1, that will be a fixed, and gear 4 is output, where input is the planet carrier cum the pulley, because the planet carrier is directly mounted on the pulley. Next, gear 4 is fixed and gear 1 is output, and third one, both gear 1 and 4 are output. Both gear 1 and 4 are output. So, here it will be gear 1. Gear 1 and gear 4 both are output. Clearly, such units can be used as differential gear unit. This means that if we keep the planet carrier input and take the output from both 1 and 4, that will rotate at the same speed of the pulley, because everything will be in the coupling action. But if we hold 1, say 4 is fully held or partially held, then gear 1 will rotate with some reductions. Now, basic conditions is that center distance from here to here and here to here, as the planets are on, this is integral, on the same shaft. So, and input output is coaxial, this center distance must be equal, or we can write Z 1 plus Z 2, that is the teeth number of gear or pinion 1 and planet pinion 2, multiplied by module of that section must be equal to Z 3 plus Z 4 into module of 2 divided by 2. We can eliminate 2 also. 2 is for, we have put it as we have considered center distance. Usually these modules M 1 and M 2, they are same and it is equal to M, we can consider. Therefore, the condition to be satisfied, Z 1 plus Z 2 is equal to Z 3 plus Z 4, that is clear from the figure. It is not essential that module should be same, because if we would like to optimize this gearbox, maybe size point of view it might be better if we take M 1 not equal to M 2, but usually if we make the M 1 module M 1 is equal to M 2, then it will be cost effective and arrangement will be easy. Now, how to find out their transmission ratio? First, we shall consider the first case, which is gear 1 is fixed and gear 4 is output. In this case, as you see, this gear 1 that will remain fixed and input will be the planet carrier or the pulley and output will be 4. Now, to find out the transmission ratio in tabular method, what we do, arm fixed, that means pulley is fixed and gear 1 is given -1 rotation, -1 in this case it is looking from that side or along the axis, it is rotating in the anti-clockwise directions, and looking from right hand it is rotating in the clockwise direction. This is -1 rotation. So, if it rotates, the shaft, that is the pinion, rotates 1 revolution, in that case planet Z 2 will rotate by Z 1 by Z 2. If Z 1 is more than Z 2, usually it is like that, then it will have more revolution more than 1 and the direction will be opposite. So, we will consider plus sign for that, and the adjacent Z 3, integral Z 3 must be will be equal to. So, it is Z 1 by Z 2 and gear 4 will rotate in the opposite directions, and it is a simple gear ratio of compound gear train, that is Z 1 by Z 2 into Z 3 by Z4, and the planet carrier no motion 0, we have kept it fixed, and gear 1 minus 1 as we have given this rotation. Now, what we do, the whole unit given plus 1 rotation, this means that we take the whole unit along with the pulley, planet, everything we rotate by 1 revolution, that is in the opposite directions, that is looking from left it is clockwise, looking from right it is anti-clockwise direction, it is plus 1. So, we can add the plus 1 as per the concept of or the principle of epicyclic gearing or planetary gearing, we add plus 1 to every one. This direction is shown here, and then the total resultant will become the planet Z2 1 plus Z1 by Z2, planet Z3 also the same, and the gear 4 will be 1 minus Z1 by Z2 into Z3 by Z4, whereas arm planet carrier is the plus 1, and the gear 1 becomes 0 as we have given the 1 revolution in the opposite direction to the first rotation given to pinion 1, pinion or gear 1. So, with this table, remember this value 1 minus Z 1 by Z 2 into Z 3 by Z 4. So, this is the output and input is 1 for this pulley is rotating. If it rotates 1 revolution, then the output gear will rotate 1 minus Z 1 by Z 2 into Z 3 by Z 4. Therefore, you can see this we have shown on the figure that 1 is fixed and the output direction is also shown what might be the direction possible. However, we need to know the sign from the ratios. Now, again I have shown in the table. Now, the transmission ratio is input planet carrier pulley divided by output gear 4 shaft, the rotation of that might be speed of that. If it is torque, it will be vice versa. Now, this if we substitute that input planet carrier pulley is rotating at 1 revolution, it has rotated 1 revolution and output is 1 minus Z 1 by Z 2 into Z 3 by Z 4. And if we equate, we find I 1, the transmission ratio arrangement 1 is Z 2 by Z 4 divided by Z 2 into Z 4 minus Z 1 into Z 3. So, type 1 we get this one, we should remember this formula or it is not difficult to find out also, and here it is shown that what will be the arrangement. Now, if we consider the case 2, in that case we have considered gear 4 is fixed and gear 1 is output, where input remain the same, the planet carrier. Now, in the same way arm fixed and gear 1 is given minus 1 rotation, that is the clockwise from right hand side looking toward the axis. So, Z 3 rotate by Z 4 by Z 3. So, depending on which one is bigger, Z 3 may rotate less than 1 revolution or more than 1 revolution. We will come to this ratio later. Planet Z 2, which is integral, that will rotate in Z 4 by Z 3. Gear 1 will rotate again the gearing ratio, the Z 4 by Z 3 into Z 2 by Z 1, minus sign will come, it will be opposite to the direction given to the 4. the same direction given to the 4, and arm and planet carrier is 0 and gear 4 is -1, which we have given. Now, whole unit is given +1 revolution, that is in anticlockwise direction from the right hand side through the axis. So, we simply add the +1 to all in the same way as we did earlier, and we get that planet 3 will have rotation 1 plus z 4 by z 3 and planet z 2 will have 1 plus z 4 by z 3, whereas gear 1 will have, gear or pinion whatever you call it, 1 minus z 2 by z 1 into z 4 by z 3, arm planet carrier is +1 and gear 4 is 0. And if we look that this is the input, this is the output, and this gear has been kept fixed. So, we have seen the possible 2 output and about the possible 3 input output. As I told, that whole unit, if it is rotated, then as the planet carrier is here, then this will simply rotate these 2 gears as a coupling action, and there will be 1 revolution output in both the shaft, unless one is held due to some reason. Now, in normal case we can break it and we can hold it for some specific purpose, but if you would like to use for differential as a differential gear unit of this unit, in that case one will not be held, but when it is turning. So, if it is in the inside, it will need more torque to rotate. So, it will almost remain stationary, the other one will rotate and we will get the differential action. And the transmission ratio of this 4 type 2, same as input and output, we will make this ratio and it becomes I 2 is 1 by 1 minus z 2 by z 1 into z 3 z 4 by z 3, or in simplifying I 2 is equal to z 1 z 3 divided by z 1 minus z 1 z 3 in minus z 2 z 4. One thing is clear, if we look this difference in other case, it was different, it was z 2 into z 3 minus z 1 into z 4 or vice versa. This will be definitely to maximize this, the bottom one or what is in the denominator, that should be as less as possible, Here I have shown that what is the arrangement in this case for type 2. Now, if we compare this type 1 and type 2, then their transmission ratios are as follows. The first one is having z 2 into z 4 minus z 1 into z 3, and second case z 1 z 3 minus z 2 z 4. As I told that if denominator is, if it is as less as possible, then transmission ratio will be high, and this gives us also a clue that z 1, z 3, z 2, z 4, they are to be very close with very small teeth difference. So, here I have written that the unit can also be used as a differential unit, which I have described. Gear 1 and gear 4 can also be internal gears. This means that if we would like to take internal gears, then possible arrangement is that, say this will go like this and meet here, and this one will go like this and will meet here. Obviously, the casing will be different. Okay. So, it is possible that we can make it also internal gear, but obviously physically if you see this, it is going through this planet carrier. So, it is not an easy task to make it, but if it can be done in some way, it is also possible. Now, we shall take an workout example. We have taken the teeth number of pinion 1 is 101, then planet pinion or pinion 2 is 98. As you find, the difference is 3 only in this case, and Z 3 we have taken 99 and Z 4 we have taken 100. So, basically 98, 99, 100, 101, this 4 teeth number we have taken, and all with same module. We have taken the same module to understand that how it is happening there. We have taken the same module. So, this question is that we have to find two possible transmission ratio. Now, here Z 1 plus Z 2 is equal to Z 3 plus Z 4, 199 is satisfied. That means, physically it is possible. So, for planet input, that means input as this pulley, gear 1 is fixed and gear 4 is output. Transmission ratio is as we have derived, Z 2 Z 4 divided by Z 2 Z 4 minus Z 1 into Z 3. If we substitute these values, teeth numbers, and equate, we find the transmission ratio is minus 49.246. This means it will rotate in the opposite directions of the pulley, minus sign. So, this direction is shown here. Now, if you go to, we calculate for other one, that is type 2, gear 4 is fixed, gear 1 is output, that we get, substituting the values, we get the transmission ratio 50.201. Plus sign indicates same direction of rotations and minus sign indicates opposite direction of rotation of input and output, both looking from respective output side. So, this is the two ratios we have got, and these two ratios as magnitude wise it is very close. One is 49.25, another is 50.2. This means that if one is held, other will rotate at 50 times less speed. So, if we would use that as a differential unit, then this gear unit will not only be the act as a differential unit, as well as it will also act as an reduction unit, and ratio as they are ratios are less. So, even if this can be used as a automobile, and as well I would say that instead of pulley we can use a helical gear there, and it could be driven by a helical pinion which is coming from the main gearbox of automobile. Alternatively, it might also be a bevel gear, and the bevel output will be there, I mean pinion will be there from the speed change gearbox of the automobile. So, we have seen this can be used as differential unit also. I have discussed that how the reverted gearing can be used as differential unit. Now, let us come to the conventional differential gear unit. In conventional differential gear unit which is used in automobile, we will find that from the change speed gearbox in automobile, the power is coming to the differential unit through this shaft. Then there is a bevel pinion. Usually you will find this is a spiral bevel gear and spiral bevel pinion, that this is the tail shaft, and then there is a gear, and this is the differential unit. With this gear, with the bevel gear, there is a arm on which there are 4 bevel pinions are there. Looking into sketch, at least there will be Z 2 is equal to Z 4 and Z 1 is equal to Z 3. We have the pinion Z 1, Z 2, Z 3 and Z 4. They are meshing with each other, and Z 2 and Z 4 is mounted on the arm. That means, the whole of these Z 2 and Z 4 will rotate along with this bevel gear, which is Z 5. Whereas, the half shaft which is going to the wheel, one is connected with Z 1, another is connected to Z 3. These 2 wheels are going these shafts are going to, half shafts are going to the 2 wheels which it is driving. Now, what happens when we keep the steering straight, then with the rotation of this pinion, say it is rotating in this clockwise directions, then this whole unit, the 2 wheels will remain more or less same torque. This whole unit will rotate like this along with these 2 shafts. These are acting as a coupling, these 2 are acting as a coupling. So, this will rotate this one, and both the wheel rotate at the same speed. Now, let us consider we are taking a turning. In that case, suppose we are taking a turning like this, this is one wheel and this is another wheel, and this is one half shaft, this is another half shaft, and suppose we are taking the turning like this, then definitely to rotate this wheel at a very small space, because this will try to rotate about this axis, whereas this is rotating with a center somewhere close to this, maybe center of this wheel or very close to this somewhere here. Then definitely this will need much more torque, because this whole wheel, instead of rolling, it is trying to rotate about its point. So, what will happen, as there is a less torque, this will start rotating, keeping this one fixed. That means, this mechanism is helping to keep this almost fixed, and with the help of this one, it is rotating in the opposite directions. Sorry, it is rotating at a faster speed. Now, we have to find out what will be the transmission ratio if this is fixed. Obviously, when it is rotating, when the steering is straight, this is rotating, simply rotating at the same speed. Now, we will verify this. Now, let us consider to find out the transmission ratio when one is fixed. We will first of all, we will consider that arm is fixed, that means the arm A which is written, that means Z 5 bevel gear is fixed, and the gear 1, right hand side gear 1 is given -1. -1 is anti-clockwise direction of rotation, looking from that side. 2 arrows are given there, we are viewing from that side. So, it is rotating in the anti-clockwise directions, that means like this, it is rotating like this. Okay. So, now what we are doing, so if it is rotating in this directions, minus directions, that means this is this, then this must be rotating like this, anti-clockwise direction looking from this side. So, this is again rotating in this directions, in this direction looking from this side. So, this means that this is rotating like this is rotating like this is rotating like this. So, Z3 Z2 is rotating in this direction and Z3 is rotating the opposite directions of this one of Z1 looking from the same side. So, plus sign has come, and Z4 will rotate in the again with this ratio. This is looking from this side, but ignore the Z2 and Z4 we are not considering. Our concern is Z1 and Z3. Gear 5 is stopped. So, thereby the arm is also having 0 velocity, and gear 6 input is also stopped. Now, what we do? We give now whole unit plus 1 revolution in opposite directions from the same direction of view. Then simply what will happen, we can give plus 1 plus 1 plus 1, but again I would like to mention Z4 and Z2 having this plus has no meaning, because this is not about their axis, this is about the axis of the half shafts. However, when we are rotating this one, then we will find this we have given clockwise, that means we have given the clockwise rotation from this side. So, if we rotate like this, so this is rotating clockwise. So, this must be rotating in these directions, which is again the minus 1 from the convention what we have taken. Now, finally, what we find that planet 1 has become 0, planet 2 again this is the same value, this plus 1 is not being added because it is in the same other plane, whereas this Z3 is becoming 1 plus Z1 by Z3. Planet 4 is again in the other plane. Gear 5 is now rotating 1 and arm carrier, that is also rotating at 1 speed. But interestingly, what we find that in case Z1 is equal to Z2 is equal to Z3 and Z4, even if it is not that, it is Z1 will be equal to Z3. This means that this become 1 plus 1 2, whereas this is 0 and this becomes 1 plus 1 2 in the directions. It might be that depends on what direction this is rotating. If it is rotated in the opposite direction, this will go in one direction. If it rotated in this direction, this will go in other directions. Okay. So, depending on these directions, this will rotate either in this direction or in this directions. In this case, what we have considered, this minus sign we have considered for in this case clockwise. So, it will rotate like this. So, this will become like this. So, it will come like this, it will be in this directions, it will rotate. If it is rotate in the opposite direction, then it will go the other directions. So, that is the basic function of differential gear unit. Now, what we find in this case, if this is 0, then this is becoming 2, twice the speed of this one. What the normal speed was there, at twice speed it will try to rotate. Okay. If we compare now with reverted gearing where if it is stopped and if it is other is allowed to rotate, that there will be huge reduction. It is the problem we have taken, for which it is 39 to 40. So, we have explained how this differential gear unit is working, and as well we have seen that how the reverted gearing is also can be used as the differential unit. However, in conventional differential unit, the transmission ratio is not very high. I mean the reduction ratio overall, this is simply by Z 5 by Z 6, maybe 5 6 only, and while the one is kept fixed, the other one will rotate the that as this is the speed ratio here. Whereas, in this case, in case of reverted gearing, we will get huge reduction and the speed of in comparison to other to I mean Z 4 to Z 1, there is not much difference. So, thank you, and in this lecture what we have discussed, that we have first of all we have considered a special, very special epicyclic gearing with external tooth, that is reverted gearing, and we have shown that this also can be used as a differential unit, and later part we have shown that how a conventional differential unit works, and then we have compared how both can be used as a differential unit. However, from the reduction point of view, that reverted gearing is having much more transmission ratio, but it will be definitely expensive than the other one. So, these are not commonly used, but there is applications also such a gearing.